Good morning. Today I'll start new lecture topic on fluid properties, calorific value, dew point, bubble point, horizontal separator, test separator, two-phase separator. So I'll discuss briefly of all on this topic. Whenever we discuss about oil and gas, we talk about field unit, SI unit. So here I have given one table. So table says like if I have pressure, so pressure in field unit will say PSI, but in SI unit say KPA. Alright. So SI unit maybe you might be familiar if you are mechanical or chemical or other engineers, but field unit they will be using like FPS unit basically, like cubic feet, volume, mole, m, mass, pound, temperature, degree Rankine. Here you can see degree Rankine, sometimes degree Fahrenheit also used, but not centigrade. Okay, SI unit K and centigrade almost similar, but they say Kelvin. R universal gas constant 10.73. You see the unit PSI, cubic feet, degree, R, pound, mole per mole. SI unit it will be 8.315. Again you see the unit. Rho is the density, slug per cubic feet, and volume flow rate. So its volume is given here, but flow rate if I see flow rate I can say Q. So barrel per day, B per D. So here meter cube per second you can write, or liter per second. Okay. There may be many other units based on this derivation of field unit or SI unit. So if some unit is given in problem, like in class problem, I can give problem using your SI unit or field unit, then you have to check in which form the answer I am asking. If I am asking, you have to give answer in KPA. So if you are giving PSI, that means that result will not match. So you will not get proper marks for that. Okay. So every time you have to look at unit, then you have to solve the problem and you have to give result based on that whatever asked in the question. Okay. And here one thing is that slug term is there. Slug actually it is mass. Slug actually is a mass that accelerated by 1 cubic feet per second square when a net force of 1 pound or pound force LB or LBF, we say pound force, is exerted on it on one slug mass is equal to 32.1740 pound, okay, or 14.6 kg actually equivalent. So a few definitions we can discuss here. Like you may have heard the term LPG CNG. So what is LPG? It is a liquefied petroleum gas. Liquefied petroleum gas. Okay. And CNG compressed natural gas. Okay, both will be looking like same, like you are getting from market, even burning, you are getting energy for maybe your cooking, like Indian gas cylinder will be coming at your home from Indian oil. So that will be actually LPG. CNG vehicles are there, they are using CNG, compressed natural gas. So what is the difference between LPG and CNG? So CNG is a liquefied natural gas and it is obtained from directly from wellbore actually. Okay. But LPG, when you are talking about LPG, actually is coming when you are processing crude oil in your refineries. You change different temperature, pressure, and you will get lots of low molecular weight gas, low molecular weight liquid actually. Those will be going out from your crude oil. So those you liquefy and use for your energy purpose, for example your cooking. Okay. So CNG, okay, so CNG will have a compressed natural gas. When you are saying you have a molecular weight lower, okay. So basically methane, normally 70% or more methane will be there, then methane or ethane mixture C2H6. But if you are saying LPG, LPG have a longer chain hydrocarbon like C4H10 or C5H12, I think. The combination is like this: CH3, CH2, CH2, CH3. So 3 is 6, 7, 8, 9, 10. Okay. If I have one more, then it would be 12. Okay. So this is the difference. Short term, short chain hydrocarbon, it is actually CNG. Long chain hydrocarbon, it is LPG. Okay. And what is wet gas and dry gas? Wet, actually this wet term is not like related to water. So wet, in general, common people understand this water is soaking something, that's wet. But in our case, in oil and gas industry, wet means we assume that some liquid particle also there in gas, or liquid is soaking something, liquid that can be water, that can be oil. Okay. So dry natural gas contains more than 70% of methane and some ethane. Okay. Dry, when we are talking about dry. Okay. And wet gas, this will be containing like CH4, C2H6, LPG, liquefied petroleum gas, like C3H8, C4H10. So here actually C3H8. Okay. And condensate also will be there. Condensate means chain number of carbon will be more in condensate. Mixture of hydrocarbon, like say C5 to C8. Okay, this is condensate. If you are going further longer chain hydrocarbon, so it will be liquid actually. If you go to hydrocarbon like say 30 or something CCC connections, then it will be wax asphaltene, that group will come. So more number of carbon, greater calorific value. So larger number of carbon is there, so it will have larger calorific value. For example, CH4 and C2H6. So C2H6 will have more calorific value, it will give more heat if you burn it. So heat of combustion, if I take CH4, it will have 8-9 some data, roughly I am giving 890 kJ per mole, and C2H4 ethene. So heat of combustion is 1411 kJ per mole, and C2H6. So here H amount increased, so heat amount little bit increased, 1560 kJ mole. Here I am writing K small and J capital. J means joule, name of some scientist, and K means kilo. So kilo always will be written in small k, not capital K. Okay. And MOL, mole or MOLE, so short form we write MOL. Okay. So always K, you write K small, like kg, K small, kilogram, kilometer, so K will be small. If you are writing capital K, so that will people can understand, but technically that will be wrong. A few other properties of oil and gas, you should remember actually. The terms are like dew point, bubble point, cloud point, pour point, flash point. So dew point is that like you have certain amount of gas and you are reducing temperature. Okay. Once you start reducing temperature, after certain time you will be seeing small amount of bubble is being created. So that point is called dew point, the temperature. Okay. And after rainy season, when it is moving to winter, so that time also temperature going down in the air. So you can see in morning time lots of small water bubble will be deposited on your grass. Okay, those are dew actually, because temperature went down and some amount of moisture is there in air. So that moisture will be cooled down and it will be deposited somewhere. Okay, so the temperature at which it starts creating bubble, it's called dew point. Okay, a point at which liquid first appear within a gas sample. A point means temperature at which liquid first appears within a gas. Okay, this is called dew point. So point means temperature. Okay, and bubble point means like you have liquid. Okay, liquid can have dissolved gas, low short chain hydrocarbon. Now you are increasing temperature. So when you are increasing temperature to level, after certain temperature, bubble will be start creating. Okay, bubble will be creating. So the temperature called bubble point. So gas first appear when temperature increased. Okay, so this is called true vapor pressure. Also they call bubble point and dew point equivalent for a single component mixture. Okay, so this is also temperature actually. I'll explain again the bubble point and dew point. Pressure, temperature, you have seen in phase diagram, you have a triple point, and this is called bubble point. Bubble point, this is called dew point. Actually this is line, because you have two phase flow and you are changing temperature, pressure simultaneously, that's why you are getting a line. If you fix one, let's say if you fix one pressure and you change temperature, then you will get only one point. Again for another pressure you will get another point, another point, another point. So in that way now you got different points and you connect all the points, you are getting one line actually for bubble point. Similarly you are getting dew point line also, because this is mixture of fluid. When you are considering well-bore fluid, so it is a mixture of fluid actually, different hydrocarbons will be there. So because of that reason, this is liquid, this is liquid zone, this is gas zone, this is liquid plus gas. Okay, because of different hydrocarbon, different number of hydrocarbons are there, the long chain or short chain hydrocarbons are there. So when you are changing temperature, pressure, so sometimes some fluid will be trying to separate, getting separated from liquid or gas. So you are getting one two phase region. Okay, but if you are using only single phase, then you will not have two phase region actually. You will have liquid region and gas region. In between there will be bubble point, dew point. Bubble point, dew point will be same actually. Now cloud point. So cloud point is that like you take certain amount of liquid, okay, transparent liquid, then you reduce temperature. After certain reduction of temperature, you will find lots of white bubbles are coming actually. Those are creating a hazy mass. Okay, so that is creating cloud, white cloud, and it will be almost non-transparent. Okay, so that is called cloud point. So the temperature at which the solids are getting separated from the liquid, that is called cloud point. The temperature at which paraffins first become visible. Okay, paraffins first become visible. Okay, that is called bubble point. When paraffins first become visible, that is called cloud point. Pour point. Pour point, you take certain amount of fluid there. Okay, you start reducing temperature. Once you reduce temperature, after a certain time, the mass will be getting thicker. So that time it will not be flowing smoothly. So that point, the temperature at which these things happens, that is called pour point. The temperature at which the crude oil becomes solid and cease to flow. Okay. Estimation of viscosity near pour point is highly unreliable. So if you are getting pour point using certain experimental method and you are getting viscosity also, so viscosity will be unreliable, you should remember. Okay. So when a fluid ceases to flow, okay, and paraffins separate at temperature called cloud point. Okay, when fluid ceases to flow, this is called pour point. I started already, so the beginning part. Anyway, I'll make available videos. So, okay, so we have already discussed specific gravity. So, API is specific gravity, you know the formula, you should remember actually every time whenever we will be specifying oil and gas. So, especially oil will be saying specific gravity of degree API. Okay, very low degree means it will be like heavy crude oil, and degree will be higher, like say 40 or something, so that will be lighter hydrocarbon will be coming. If you go to like say 10 or below 10, so it will be heavier hydrocarbons, okay, heavy crude. If crude oil having 10 degree API, actually it will be equivalent to water, okay, the viscosity or gravity. Degree API formula is like 1.5 divided by specific gravity minus 131.5. So, Sg equals specific gravity water equals 1 relative to water. So, water specific gravity must be 1, okay, and you are comparing with water specific gravity. So, if you know specific gravity relative to water, so if you can put it, you can get API gravity, or vice versa. If you know a specific API gravity, you can convert into specific gravity. So, specific gravity of gas is G, just I put symbol G. So, MW 29, okay, MW is molecular weight, okay, and we are assuming a specific gravity air related to air equals 1. So, density of air is density of air is 14.7 air at 14.7 psia and 60 degree Fahrenheit is 0.0764 lbf cubic feet, pound force per cubic feet, okay. So, rho g equals 2.70 SGG by TZ, okay. So, T will be degree Rankine, Z will be gas compressibility factor, okay. P is pressure, I am writing units also, PSIA, okay. Rho g density of gas, unit will be LB divided by cubic feet, okay. So, this will be giving 0.093 not megawatt, it will be molecular weight P divided by TZ, Z is compressibility. So, you should remember the units. If you are mistakenly taking some other unit, then things will be wrong, okay. So, we will try to see how to get 0.093 MW, okay, this one, because remembering this constants will be difficult, but if you can remember the derivation procedure. So, if you forget remembering this constant, actually you can derive, okay. So, standard temperature and pressure, if I take temperature and pressure, rho standard condition density will be 0.0764 specific gravity of gas, okay. And if we take 1 pound of gas, then V equals 1 by rho, okay. The equation of state becomes, the equation of state is PV bar ZT, okay, equals constant. Now, if we take standard condition and present condition, it will be like this: P standard, V standard Z standard condition is 14.7 degree 7 psia and 60 degree Fahrenheit. Okay, and T is standard STD. Okay, PV bar by TZ. Okay, so if you put all the values here, like P standard condition 14.7 and Z standard condition 1 and temperature 520 degree. Okay, and the V formula is that 1 by rho value is that 0.0764 Sg, okay, and equals PV bar ZT. Okay, so this will give rho equals rho also will come one rho term, rho equals 2.70 Sg P T Z. Okay, now Sg equals I should write somewhere else because the video will be coming here. So now Sg, now I will write here. Now Sg equals molecular weight divided by 29. So this will give rho g equals 0.093 molecular weight P pressure divided by Tz. Okay, so you should remember these terms. Okay, if you remember for final term also, it will be fine. Otherwise, you have to derive. Okay. And this derivation is taken from K. Arnold book. So if something goes wrong, just please follow the book.